I'm assuming we're live already. I'm going to just share. Wait a minute. What Make a Watch Party? Good morning, Make a Watch Party. And I have had a request to do more bubbles. So it's no, it keeps going to stories. It's Caroline from Bubbly Maths and presenting resources by the amazing AimSec and their Aiming High. Oh dear. I just want to share. I just want to share. No. Go back. This is impossible. It's not working. Help. Okay, what about from here? Can I share from here? Will it let me? Will it let me and not go somewhere goofy and crazy? I just want to there. Watch party. Right. Watch. Oh yeah, and then I've got to actually make it active. So start. Sorry, I don't know how else to do this without a producer. Yeah, okay. So good morning, Caroline from Bubbly Maths, and I have had a request to make more bubbles. What am I doing? Not making bubbles. So here we go. I have my bubbly glove because we at Bubbly Maths, we make maths fun using soap bubbles, balloons, and lots of other things. So this is already in here. We've got a square bubble. Okay, this is a square bubble. If you blow a square bubble, what shape is it going to be? Ooh, it's a spherical bubble. Ooh, ooh, and another one. Catch that one. Ooh. And we caught it in there. Cool. And now we've got a triangular bubble. Let's see if we can make some magic with triangular bubbles. See if we can. Maybe we can't because it's the wrong shape, so we'll stick with square bubbles. Let's have another one more go at a square bubble. Let's blow a square bubble and see what shape it comes out. And it is a spherical bubble. Catch. Whee! That was a ladybird. Woohoo! Okay, there you go. We've had some bubbles. We'll do a little bit of bubbles if I can get my head around it every time we do a session. And now I'm going to sit down on the bubble juice. So today's session, and just got one more share to do. If I can find the original link so that I can share it. Going to share it on the Bubbly Maths page. So these events are presented to you by Bubbly Maths, and they're about the Aiming High resources, the resources that AimSec creates, and they're called Aiming High. And if I can, there we go. I was going to share that on the Bubbly Maths Facebook. That's not it. On the Bubbly Maths Facebook. Now this is my frown. Got my frown now. Oh, there we go. Share to a page, share to Bubbly Maths page so that the people that are on Bubbly Maths page, hello, I've got someone watching. Share on a page I manage, which is Bubbly Maths. I already did that. Too sensitive. Maybe I've spilt some bubble juice on it. Maybe I have. Okay, there we go. So that's now live on the Bubbly Maths page, and there's only one thing left to do now, and that is I hope you've enjoyed the bubbles. No, don't stop that. I'm going to share screen. That's it. Share screen with that's it over here, and share. Fingers crossed. I've got it set up so that I can see I'm on it and the screen is on it, and fingers crossed. Have you got your fingers crossed? Because I need all the help I can get here. Just focus that a bit more. It's quite bright. Hopefully you can see it. So it's all about symmetries. We are going to make symmetries on a 3x3 grid. Boom, 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 boom. That's it. You can draw it yourself, or you can print it out in the resources. There'll be a link to the resources as soon as the live's finished. I'll print a link to the resources. We can print it in the resources. What we're looking for is all the symmetries. Now, there's other different shapes you can do. You can also do them on, find symmetries on what's known as an isometric grid paper, and that would be, let me just if I can get this, hopefully I've got my scales right here. So there's one across there and one across there. If you've seen, you can, I mean, the paper basically continues on, but if you create a triangle on paper like that, that would be the outline of the triangle. The paper goes on, keeps going, but you just want to focus on that triangle. And you can do symmetry. So one of the things would be, for example, on this one here, let's get rid of that. So you're only going to be focusing on that one little bit. You could look at maybe if you've filled in that triangle there and that triangle there, you'd be looking for the symmetries in that. So that's just something else you can do. But we're going to focus today on squares. The point is there's many ways you can do this, or we're focusing on squares. So as usual, we'll be doing a session, well while we're doing it, so we're going to recognize and visualize transformations and symmetries, the sort of symmetries that you use in school in 2D shapes. So it's going to really help you with your shapes when you get asked symmetry questions. You're going to get lots and lots of practice, and hopefully in a very enjoyable way. And one really, really important thing with this is it's going to help us see how to be systematic. Now, for many of you, I'm going to encourage you, if I can actually see that, to make a poster. There's a poster, it's a bit faint, but there's a poster in the resource pack. And if you can write out all the symmetries, and this is visual, it's about making a pattern with all the symmetries, and that will help you if you use that poster to be systematic. So I would encourage, and you can make that poster yourself. You can take this and reproduce it onto a big piece of paper and put that on the wall. And it's not about finding all the symmetries in the next 20 minutes or even the next day. It's about finding all the symmetries over a period of time. So it's a project. And then once you've found all the symmetries, what you want to convince somebody else, you want to do it in such a way that, number one, you're satisfied by being systematic that you found all the symmetries, and then present it to someone else and convince them. And that's all part of the process. So in an hour's time-ish, we're going to do a session for younger children, so between the ages of 4 and 5 and 6. If you're those ages, then we're going to do something for you. And in the meantime, we're going to do something. So this next bit is for upper primary and lower secondary. That's in the UK. So that's between the ages of 7 and 14. So I'm going to draw 2 grids now. I'm going to draw a second grid, if I can find my pen. There it is. 2 grids, 1 and 2. In the resource pack, there are lots of squares already made out. You can use squared paper. Let's make those squares rather than not squares, rectangles that aren't squares. And I've got 2 samples. Here we go. We've got this. We're going to color in squares. We're going to take this one, and then we're going to do a different one over here. We're going to do this. And look at those symmetries. So just take a moment and talk to whoever's with you, or talk to yourself if you're alone, and decide where the symmetries are, if there are symmetries, and well, are they symmetric? And if they are, why are they? And if they're not, why not? Is there a line of symmetry in either one of them? Is there more than one line of symmetry? Where are the lines of symmetry? And also, what happens to the pattern if you rotate it? Now I'm going to do that with this one. I'm going to rotate this one. Okay, I've got it on the paper and make sure you can see it. I'm going to rotate it. See how it changes. It looks different, but it's rotated. And the idea behind it is that, just to illustrate that, if you, that pattern, that top pattern is the same as this pattern, only rotated. So as far as symmetry is concerned, it's the same. And the same with this one. As far as symmetry is concerned, which way is it? That way. Whichever way you rotate it, even though it looks different, symmetrically, it's the same. It's the same pattern. So that's classified as one pattern, that's classified as another pattern, and any of its rotations, variations due to rotation, it's still the same pattern. It can only count once in your poster of beautiful symmetries. Now, so we're going to actually, that's the principle. Now we're going to actually start, I'm going to illustrate it with squares. We're going to look for, with 4 squares is what I meant to say. So the first symmetrical shape that I can think we're going to look for is symmetries with no squares shaded, with 1 square shaded, with 2 squares shaded, with 3 squares shaded, and with 4 squares shaded. And we can do that with, let me just move that out of the way so I can see what you can see. We can do that with 4 very easily and quickly. So this is just going to give you a primer on how to do the one with basically 9 squares. So 0, does that have symmetry? Well, it's got a line of symmetry there, it's got a line of symmetry there, it's got a line of symmetry there, and it's got a line of symmetry there. There you go. Those are lines of mirror symmetry. And we can rotate it, and any way we rotate it, it's always still going to look the same. So that's 1 pattern. So for 0, we've got 1 possibility. For what about 1? What about if we've got 1 square shaded in? Well, if we have 1 square shaded in, we can do that, or we can fill in that one, or that one, or that one. Let me just put them underneath each other here. Boom, 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 boom. Can you see that? Yes, you can. Hooray. Boom, boom. Right, first of all, let's see. So you've got 1 there, 1 here, 1 here, and 1 here. Where is the symmetry on this one? Is there symmetry here? Is there a mirror symmetry across this line? Is that, would it be the same? Is it the same on either side of a line like this? Is it the same on either side of a line like this? Both. What about this one? Is it the same on either side of that? So you've only got 1 shaded in. So the only line of symmetry on this one is that diagonal. So that's got 1 line of symmetry. We've got 1 so far. Now what about this one? Same thing. Now wait a minute. If we rotate that one, we've got that. If we rotate that, we've got that. If we rotate that, we've got that. These are actually the same. So there's actually only one pattern, because every other pattern is a rotational version of the same pattern. So we've only got 1 for that. Now what about 2? What about if we put 2 on? 1, 2. We're going to color in 2. If we color in those 2, we've just looked at that. Okay, do we have symmetry on that one? A line of symmetry there. Do we have any other lines of symmetry? Do the diagonals work? Is it the same on either side of the mirror if that were a mirror? Is it the same on either side of a mirror if we did one there? And it's not. And likewise, if we put them on the other side over here, that's actually the same pattern. Or if we had it at the bottom, it's the same pattern. So we have 1 of those. Now, are there any other patterns where you have symmetries with 2 squares? Well, I can see 1 here. So now in this case we have two lines of symmetry, one there and one there. We don't have, this is not a mirror symmetry, line of mirror symmetry, and that's not a line of mirror symmetry because they're on opposing, basically adjacent to opposing vertices of the square. So we've got two, and everything else is rotational symmetry. So we've only got two distinct patterns. What about three? I'll let you find if there's any with three, and then four, I'm going to draw four. I'm going to let you experiment with three because you actually have to do a bit more experimentation with three. So for sure, we found now four is the negative version of with none. So we now have, now there, well, actually I will write on the, we've got, actually I can write that one there, can't I? I can write the four there, and I'm going to write the three here, because I'm just going to tell you now that the only, I'm telling you these because it's with two, we just get, you can experiment, you can do it yourself. And then this one is 1, 2, 3, 4. So that is the negative version of that. So for every blank one, there's a colored one, and for every colored one, there's a blank one on this, and likewise with this. So we actually have two patterns for two. Now, those are the ones I've seen. There might be more. So I would be very happy for you to double check on me and see if there's anything else that I haven't spotted, and go for it. But that's an example of what to do. So you record how many symmetries, and I'm pretty satisfied that those are the only 6 symmetries that exist for a square of 4, but I could be wrong. Has been known. So lots of times, and I have no problem with being wrong. I get very excited when somebody comes to me and says, oh, I've got some more input for you on this question matter. And I do encourage you to use that sort of terminology. It's input, it's discussion, it's debate, but it's not really right and wrong, although I know maths can be exactly right and exactly wrong. Using the words right and wrong can be very detrimental, when, especially since maths anxiety is such a huge thing in our society, and we want to use language that encourages discussion, and it encourages curiosity and debate, rather than language that puts your back up and makes you tense and makes you want to defend yourself. It's more about opening discussion rather than closing off due to feeling as though you're being put in the wrong. Okay, so that's basically what we're doing, and the kind of questions that you want to look at, I'm going to ask you are, so are all the patterns I've shaded symmetrical? You'll be doing this for your 3 block patterns, for your 9 square patterns. Where are the lines of symmetry, the mirror lines of symmetry, and which patterns are the same and which patterns are different? So we already went through that for the 2. I deleted the ones that were the same. And so have I missed any? Are there any patterns for 4 blocks where the with the same number of squares shaded? Have I missed any for 2? Have I missed any for 3? Have I missed any for 1? And have I missed any for 4? Remembering that the pattern must be, if it's got rotational symmetry, it's the same pattern. If you can rotate it and it'll look the same. If you can rotate it back to that position, let's say, or rotate it back to this position, just by rotating, then it's the same pattern. So those just count as 1. And then, so what counts as the same? It's really important to figure out, have you found all the possibilities, and how do you know you found them all? So I think I found them all. I'm just going to tell you my opinion. I think I found them all because I can't see now somebody else might help me out here, but I can't see any other way of putting two. It's two next to each other and two opposite each other. And I can't see any other way. And if I now rotate that, I keep making the same pattern as I rotate it round. So that's one pattern, that's another pattern. I can't see any others. And I'm satisfied that those are, any other position of the same pattern is still the same pattern. Again, that one, you can rotate it round, they're all the same. Rotate that one round, they're all the same. That one's, there's only one because they're all filled in. That one's, there's only one because none of them are filled in. And I certainly cannot see any other options of doing that like that. And being systematic, every position I can think of is covered by simply those two there. So that's me being systematic and convinced that I found them all for 4 squares. Now you can go and do that for 9 squares. And then what does count the same, and how can we find other solutions? So it's very, very simple with 4. You've really got to think how you can find other solutions with 9. There are, you have to be super systematic about making sure that you've found all the options, because there are quite a lot of options with 9. And then as I've done, we're going back for, if you, with 2, there are it's more than one option, but as you go, I've gone to 1, 2, 0, 1, 2, and as I've gone past 2 and I get to 3, what happens there? What prediction can I make about 3 or even 4? What prediction can I make, and what are the similarities and differences between 1 and 3 and 0 and 4? So be looking out for that as well when you go to larger number of squares. And it's also, this is a fun activity. It's not about finding all the possibilities today. If you want to create that poster, we're going to encourage the older learners, 14 and up, to do the poster. If you want to do the poster, do the poster. If you don't want to do the poster, what we really, really, really want you to do is be systematic, be methodical, and be convinced that every pattern you've got is unique, and enjoy it. Enjoy the process. Do it while you're enjoying it, and then put it down while you're not. And then come back to it later. You might think, wait a minute, I think I've not, this is the advantage of the poster. You can put the poster on the wall and just, you could be looking at it. Go, oh, I found another one, and go up and put in another one, and then go through all the questions. Is it unique? And can you find any other solutions? Finding another one might open your eyes to another possible configuration, which is a new pattern. Always checking that if they rotate, it must be a unique pattern, even if it's rotated round. And then for older learners, which I have lost, I never do that. I never lose my papers, do I? If you watch me regularly, you will know that I never, ever, 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 here we go, lose my papers. They were in the wrong order. Okay, so this is where we're going to do the poster. Let's have a look. I'm going to just flash. Woo! There is a solution, but not to be looked at. It is in the packet. Don't look at it. Don't use it. If you use it, it takes away all the fun. It takes away all the thinking. And there's the poster. There's a copy of it, a blank copy of it. You can't see it too well there. It's a bit bright, but I'll just leave that there. So print out the poster, make a separate, get a big piece of paper and make a separate copy of it so you can maximize the sizes. And then for 14 to 18-year-olds, we really do want you to find, so for the younger learners, just have fun finding patterns. For the older learners, find all possible symmetric patterns and filling in that poster. It doesn't have to be done in one day. And then discuss it and tell someone why you found them all, how you found them all, and how you and demonstrate how this chart illustrates how you have found all of them. So as you put them in, be systematic in the way that you create the patterns so that your story flows. you'll see what I mean when you do it. And so this is, people ask, and you might have asked, why do I have to do maths? Why do I have to do this? Well, being systematic, finding all possible solutions is a huge skill. It's a life skill. And also being able to, it's part of the power of persuasion. So let's say you decide to start a little business, or even get a job, or if you've got a job, you want to do something, you've got an idea and you want to convince your boss that this would be a great idea to do, and that will increase the amount you earn. Or if you have your own business, and when you grow up, then you can convince someone to give you a loan, or sell something to a customer, or get a patent for an invention. And you have to be thorough, and you have to be systematic, and you have to cover all the bases for those things. And this is exactly what you're doing with this. The specific example is finding 9 squares, was working with 9 squares, but the system, being systematic, and the method is the same. And the more thorough you learn to be, and the more you're able to do this, and then talk about it convincingly and convince somebody else that you found it all and you've covered all your bases, then that actually gives you some huge potential. And the same thing goes if you want to become a student. Some people are students or teachers, and it's exactly the same thing. If you want to get funding for anything, all of these skills are super important for any life skill. Or even if you're a homemaker, you might be a man or woman that stays home and looks after children at home. Even for that, you will still have projects. Oh my goodness, and then you've got to negotiate with your own children. Then, my goodness, the hardest negotiators are you guys. You guys are the hardest negotiators in the world for us adults to be able to systematically, methodically, and cover all the bases and negotiate with you. When you're a grown up, you'll need those skills. So, it's something weird, by the way, if you don't keep practicing those skills, they go away. I don't know if you've noticed that you can actually, sometimes it can be a bit frustrating negotiating with grown-ups, because they'll just say, because I say so, rather than give a reasoned argument. Well, keep up, and you'll need that if you ever have children. So keep up the practice with things like this, and that'll give you much greater skills when it comes to giving reasoned arguments, logical arguments that are convincing. And this is all part of that skill. It's a life skill. So there are other things. There's lots of other things as well, but hopefully I've said enough to convince you that it's a worthwhile exercise. It's certainly a fun exercise, and it's visual. You can make lots of different colors. Actually, what I could have done here is just to illustrate. I'll just do it over the top. So for 2, we'll use red. For 3, we're going to go back with the same color, and then because they are the negative of each other. Back in the day when we used to have negatives, you get it on your special effects on your phone. Black turns to white and white turns to black, and so it's like the negative image, but it's still a different pattern, and then a different color again for 4. Obviously there's no color for the 0. All right, so thank you for watching. If you are on YouTube, please do subscribe to our YouTube channels. That's Maths Toys YouTube and Bubbly Maths YouTube. And please, if you're on Facebook, please share the Making Maths Fun for Kids of All Ages group, which is where all these lives happen. And you can just share this live as it's happening, or put a post on your Facebook, or get your grown-ups to do it, and then link the group, or simply talk about it and give the name of it, Making Maths Fun for Kids of All Ages, and tell them why it's of value to you. If it's of value to you, please tell other people about it. And then all of these resources come from AIMSEC. Now, AIMSEC is an organization that provides professional development for teachers in Africa. So there's a lot of children that live in communities in Africa that are and Africa and in India as well, and lots of some developing countries where they don't have access to resources. They don't have, the schools are very limited in what they have. They're a long way from everything. And so what AIMSEC does is it provides professional development for teachers that teach in those schools. They're a very dedicated group of men and women, and they come on the AIMSEC courses and learn to improve their skills, which is what us grown-ups are always doing, is improving our skills. Learning doesn't stop when you leave school. And what these resources do is they provide interesting activities which the teachers can take out and use very easily with resources that just like paper, just simple resources. You don't have to have special equipment. And also they are called rich activities. So they're low threshold, high ceiling, which means that no matter where you are in your learning journey, you can get into it at some level. So we start at the age of 4 here, and at some level you can get into it and then just be stretched. Just allow yourself to be stretched and get engaged. And that's what these activities are really good at helping with. And that gives you confidence, and it makes you a better learner, and it gives you experience that then when you have a similar activity as part of at another time, you've got experience of recording things, you've got experience of being systematic, you've got experience of explaining what you found, proving what you found, at least demonstrating what you believe to be a proof. There are plenty of proofs that professional mathematicians, lifelong career mathematicians, we've had proofs in the past where everyone's seen the proof, accepted the proof, published the proof. This is proof. We've proved that this and this is the case. And then a few years later, somebody comes along and goes, uh-oh, I've actually found that that isn't a proof. And then it had to be overwritten. So it's all part of the process, and it's all part of being a young mathematician. So thank you for joining us. And now I'm going to have a look on Facebook. So I'm going to take this camera off and go onto the other camera if I can, hopefully without ending the live, which I did last time. That's it. Stop sharing. That's what I'm going to do. Stop sharing. Work it out. Okay. So now I'm on here. Hello. Right. So I'm just going to see if we've had any people saying hello on Facebook. Let me see what I've got. Well, sometimes it doesn't. Oh, here we go. Here we go. Now it's updated. So we've got Andy Davis, Alina from Poland. Hello. Margaret Jones. Hello. It's always wonderful to see you. Helen. Hello. We had a chat on Facebook yesterday a bit about helping a mutual friend, and my cousin Rod from South Africa. So where have we got? We've got Poland, we've got England, different parts of England, and we've got South Africa, and now we've got Kent, the Garden, not the Garden State, the Garden County. And right, thank you so much for joining. Now, having done that, I've now got to go and brain. Here we go, found it. How to cope with doing Facebook Lives without a producer. I can do it. I can do it. Thank you very much for joining up. Should we have one more bubble? Should we have a goodbye bubble? We'll have a hello bubble and a goodbye bubble. I'm going to take off the microphone so I don't bubble the microphone. Are you ready? Oh, didn't quite let pop. It's got vehicle. Okay. Oh, looks like I need some new bubble juice. It's not performing very well. It's a little bit old. It's been around for a few days. So I'm going to forgive it. I'm going to forgive it. I'm going to wipe the seat before I sit on it. And I'll say goodbye. Thank you very much. See you 10 o'clock, 28 minutes for the early years, and then 8 o'clock tonight for the preparation for tomorrow, which will be at 9 o'clock for ages 7 to 18. Bye.